Hello, I'm Madison,
And I'm Haley.
and this is our lesson plan. So we decided to do fifth grade science over chemical and physical reactions. And the title is Fun with Reactions, and it should be about an hour and 15 minutes long. So in this lesson, we decided to piggyback over a lecture lesson that was taken the day before. And basically, this is just going to be a more hands-on activity rather than just us feeding them information. So the goal is for students to know the difference between a chemical and physical change, and the objectives are for the students to differentiate between them, and they will also know what an algorithm and sequence is and be able to explain and know how they work in a real world scenario. And we'll be able to take this based off their worksheet they do and the experiment we do with them. It'll tell us if they understand or not. The standards are 5-point PS1, matter and its interactions. The first is to analyze and interpret data from observations and measurements of physical properties of matter to explain phase changes between a solid, liquid, or gas. The second one is to analyze and interpret data to show that the amount of matter is conserved even when it changes from form, including transitions where matter seems to vanish. Design a process to measure how different variables affect the rate of dissolving solids into liquids, and evaluate the results of an experiment to determine whether the mixing of two or more variable substances result in a change of properties. The academic language we chose was chemical and physical change because those are the topics of the lesson. A chemical change is when one substance forms another one, and a physical change is when the substance changes, but it does not change into a different type of substance. The academic language we chose was algorithms and sequences. So algorithms are what we want them to do, like the process, but the sequences is the order of what they do. And then the rationale for it is students will be able to see a visual representation of chemical and physical changes in a real life scenario. Algorithms are instructions for an action to occur, while sequences are the order in which they occur. And we want the students to see that without these two, the end product will not come.
Okay, so for the pre-assessment, which will be how we determine the prior knowledge of the students, we're going to have them to complete a bell ringer that will test some of what they learned the prior day in our lesson, and they'll be able to explain why they picked their answers. And then for the hook, we will have them watch a short, catchy video to grab their attention. We have the link provided there. And then we will have them make pancakes from scratch, watching us first, of course. And then they will be able to relate this subject to a fun, real life scenario. And hopefully the event will stick out in their mind and will help them to notice other occurrences, whether school related or not. So the real world connection in this lesson, the objectives are learned through making of the pancakes. While making these, it's an easy way to teach the students how ingredients transform into the food that we eat. This can also make them realize the changes going on all around them that create the world we see today. It's also relevant because it allows the students to realize just how important the sequence and the algorithms are. How will we provide for student reflection will be that while making the first pancake, we will involve the students by asking them questions related to the subject. And while we make the rest of the pancakes, the students will be working on a worksheet that they will be answering what physical and chemical change they observed and explain their reasoning. At the end of the class, they'll turn in the worksheet, which will be evaluated in order to see how much they understood. For the assessment, the questions being asked during the making of the first pancake will be able to tell us as the teacher if the right connections are there and if they're being made. And then the worksheet will tell us if the subject was mastered or not. So for the formative assessment of lesson objectives, while performing the task of the experiment, we're going to ask questions as we go through related to the current step in the process that we're on. We might say things like, what's going on? How much should we mix when we're combining like wet and dry ingredients? What's the goal of us mixing this? And we'll be able to point out important steps and the physical changes that are occurring. When we're cooking, we can ask, what do you notice changing? What is the gas going into the atmosphere? And be able to point out things like the state of matter that it's in, the smell, the color, and things like that. For the summative, we will be doing an experiment, obviously, which is the making of the pancake, and then short answer in the worksheet where they're having to explain why it's a physical change, why it's a chemical change. And the way we will define the mastery of it is based on the answers from the worksheets. The baseline goal would be that students get 80% of the reactions right, and that students get 50% of the reasonable explanations to their answers right. Then for the assessment requires the students to, and there you'll see we highlighted the ones that we chose that it would require them to do in their higher order thinking there, that they're having to think outside the box and compare it to real life scenarios. For the academic feedback to the verbal answers during the class discussion, we would elaborate on why they're right and why they're wrong and bring up more challenging points to be able to discuss. And then the next class, when they return, we will return the worksheets to the students, so that they can see their grades. And while we do this, we can go over their answers and explain the reasonings behind any of the questions that they might have.
On the beginning of the lesson, we're going to take about 10 minutes to reintroduce them to the subject. So we'll have the students complete a bell ringer over their previous knowledge, which will be like picking the examples of the chemical and physical change and explaining why they picked it. And we'll also have a YouTube video that just is really catchy and it intrigues them into remembering what they learned yesterday. And the point of this is to see that if the students don't get it very well, then we can just go into detail hard with them. And if they get it really good, like we want them to, we can just slide right into the experiment really easy. Also, in the segment, we are basically outlining all the 4 standards in a real quick attention grabber. And since we'll be expected to explain their answers rather than just choosing them, which is why it's higher order thinking. And the only materials needed are paper and pencil. The transition into our middle part of our segment would be to have the students will be asked examples of physical and chemical changes. And if the students bring up the activity, then we'll explain why they're right. And if they don't, we'll explain our activity as being both a physical and a chemical change. So this should take about an hour to do. And what we're really doing is just making it a real fun life experience and hoping they remember it. So the first time we make a pancake, it'll be together as a class. And what we're going to do is put all the ingredients together, all the basics, and just talk to them through it. So ask questions like what is going on, and ask them how much should we mix, what should be our goal of mixing, and all that stuff. And then whenever we start cooking it, we'll ask them questions like, why didn't we just put each ingredient on the stove? What would that have tasted like? And why don't we just eat the liquid out of the bowl? The goal is to get them thinking through the reasons that you've made the pancakes in the order of the steps that you did, to relate to computational thinking. Also to understand the power of heat to transform liquids into solids. As the substance heats up, the ingredients bind together and the liquids begin to evaporate, and the batter comes together to form a solid pancake. As we cook, we will talk through it with the students. How would they make the pancakes tomorrow morning? How would they reorder any of the steps? What could they change in their ingredients, and how would they pancake change? What if we left out the eggs? What if you left out the salt? After the pancakes have been made, have the students work on a worksheet that asks for all physical and chemical changes and why they put their answer. While the first pancake is being made, we will discuss all 4 of the standards listed above and discuss the importance of the computational thinking. While the teacher finishes the rest of the pancakes, the students will work on their worksheet to finish up the experiment to teach more about the standards. Because the activity is hands-on and asks questions with no definite answer, higher order thinking is being used. The materials change based on the amount of students, so you would need to take that into consideration. But the materials would be like the pancake mixes and stuff like that in order to make it, and drinks. So what we planned would be to have the students say, bring in a drink today, we are doing this lesson, and if they don't, because there's always those few, to bring some in for them. So all the students will need is a worksheet, the pencil, and a drink. And the transition to the end of our lesson would be we'll ask the students to think of how this lesson could apply to the other aspects of their daily life. And during this time, we'll have a discussion about the examples, not limited to cooking, because we all know there's going to be those kids that are just going to say cooking, all this stuff. So a person from each group gives regards how this lesson could relate to their daily life in other ways. That should take about 5 minutes. And then the question pertaining to an example of each type would allow students to use however thinking. They can evaluate the main topic of the standards, seeing as there are no limitation to the answers, and all the materials needed are students' thinking cap.
Okay, for the technology integration, we as the teachers would be using like word processing, PowerPoint, internet resources, and an interactive whiteboard that we have highlighted there. We chose each of the technologies because they're needed to effectively deliver our lesson so that the students are not actually going to be using any type of technology other than their hands or whatever to do the lesson because it's an experiment, but we as the teacher will be using some technology. You can see there for the teacher strategies and best practices, we have highlighted several things there. And then for the grouping option, we highlighted individual, pairs, and whole group. Individual because the students will individually be doing the worksheet, providing their answers and giving why to each of them. We chose pairs because for students with anticipating learning difficulties, we will pair them with a student who we see as patient and helpful to assist when or if there's any difficulties that arise. And then whole group for the discussions that we have after we make the pancakes and we're talking about everything. For rationale and theoretical reasoning, we chose to go with a more hands-on and creative approach to this lesson. This coincides with Bloom's taxonomy in the way that students are able to create and apply, as in the pancake, evaluate, as in the recipe and the result, and then analyze and understand what they learned, as in the worksheet. And the goal of using these would be to implement the fact that the students will remember the difference between a chemical and a physical change and how to enjoy a fantastic pancake.
The two worksheets that we made to go along with our lessons would be a pancake recipe. So this recipe isn't the exact same that we used, but we thought that it would still work because the students can go home and use it, and they can also see that different algorithms still can produce the same product. It just may be a little bit different. And then this would be our summative assessment. We did a chemical versus physical reactions. So this is some of the reactions they saw throughout the day, and we put to explain why they put what they put. Now that's important because we don't want them to just put a random one of the two answers because that's a 50% chance of getting it right, but to explain why means that they're actually understanding what they're saying.
Okay, so this concludes our lesson and we hope you enjoyed listening.